charged spherical conductors of radius R1 and R2 are connected by a wire, then the ratio of surface charge densities of the spheres is now. According to the given problem, there are two spherical conductors, iron spheres or copper spheres, connected by a one wire. Now, radius of the first sphere is capital R1, radius of the second sphere is capital R2. These two spheres are charged. Charge on the first sphere Q1, charge on the second sphere is Q2. When two water tanks are, now this is one water tank, it is one water tank, it is another water tank, it is another water tank, it is another water tank. Here there are two water tanks. They are connected by the pipe. They are connected by the pipe. When two water tanks are connected by the pipe means water flows from one tank to the another water tank. This flow of water is taking place until these two water tanks attain the same level, same water level. Now water flows from one tank to another tank until their water levels are equal. Until their water levels are equal. Water is not equal. Water levels are equal. Then flow of water is stopped. Similarly, when two charged spherical conductors are connected by the wire, charge flows from one conductor to the another conductor until their potentials are equal. Charge flows from one conductor to another conductor until their electric potentials are equal. Electric potential on the first sphere is equal to electric potential on the second sphere. Here. Now charge flows from one spherical conductor to another spherical conductor until their electric potentials are equal. Electric potential on the first spherical conductor is equal to electric potential on the second conductor. Now please tell me, what is the formula for electric potential on the surface of the conductor? Now electric potential formula 1 by 4 pi epsilon naught Q1 by R1. Electric potential on the second spherical conductor 1 by 4 pi epsilon naught Q2 by R2. Here epsilon naught cancelled. Now this is here. Now please listen. Q1 into 1, Q1 by 4 pi R1, that is equal to Q2 into 1, Q2 by 4 pi R2. Now first one is multiplied with R1 and numerator and denominator is multiplied with R1. Here numerator and denominator is multiplied with R2. There is no change. This can be written as Q1 by 4 pi R1 into R1, R1 square into capital R1, Q2 by 4 pi R2 into R2 square into R2. Now please listen. 4 pi r square is the formula for the surface area of the sphere. 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 A is equal to 4 pi r square. Surface area of the sphere. Q1 I am writing Q1. 4 pi r square, it is the surface area of the sphere. It is the surface area of the first sphere. Surface area is A1 into R1, that is equal to Q2. I am writing Q2. 4 pi R2 square, it is the surface area of the second sphere. Surface area of the second sphere I am writing as A2. Surface area of the second sphere I am writing as A2. R2 I am writing as R2. You know very well surface charge density formula. Surface charge density formula. Surface charge density formula. Sigma is equal to Q by surface area. Surface charge density is equal to charge per unit area. Here, charge by area. Charge per unit area. Charge per unit surface area. Charge per unit surface area. It is nothing but the charge by area, nothing but the surface charge density. Charge by area, surface charge density. Charge by area, surface charge density of the first sphere. Now sigma 1 is equal to Q1 by A1. Sigma 2 is equal to Q2 by A2. Sigma 1 is the surface charge density of the first sphere. Sigma 2 is the surface charge density of the second sphere. Charge by area, surface charge density of the first sphere into R1, that is equal to charge by area. Charge by area means surface charge density into R2. Now sigma 1, sigma 2 comes to denominator, R2 by R1 comes to denominator. Sigma 1 by sigma 2 is equal to R2 by R1. This is the required answer. This is